Hi everyone, my name is Gizem Komedi, and in this video I'll walk you through my scheme program that manages a family tree. My program stores, organizes, and processes family member data using list structures. I'll also highlight where I use high-order function, recursion, and lambda expressions to make my code efficient and functional. The family tree is structured in two lists, MB for the maternal branch and PB for the paternal branch. Each entry represents a family member and contains a name, a nested list containing the names of the mother and father, a nested list containing the date of birth and date of death. Empty lists indicate missing information. To access these branches, I use three functions, lstmb, lstpb, and lstall. The last function, lstall, makes use of the higher order function append to merge the two lists. Here is the code that will print out the maternal branch, the paternal branch, and the combined branches. And here is the output of that code. I created a function called children that extracts all individuals who are parents. This function uses filter, which is a high order function that takes a lambda expression to check if the parent list is not empty. I then apply map to extract all the names of those individuals. When I run this function, it returns a list of all the children from both branches. Here is the output of feature B1. Finding the oldest living member was a more complex problem, so I broke it down into steps. GetAge calculates a person's age based on their birth and death years. If they're alive, it returns 0. Older compares two birth dates recursively by checking year, then month, then day. Oldest living member is a recursive function that loops through the list, checking if a person is alive and whether they are older than the current oldest. The final output gives me the oldest living person in the combined family tree. Here is the output for feature B2. To find the average age at death for the paternal branch, I reused getAge. The function average age on death works as follows. First, it applies map to get a list of ages, then it uses filter to remove people who are still alive. Finally, it calculates the average of summing up the ages and dividing by the count. If no one has passed away, the function returns 0. Here is the output for feature B3. The function same birthday month extracts all family members born in a given month, in this case February. It works by checking the second value of the date of birth list. This function uses map and filter to extract and process the data efficiently. The output gives me a list of names of family members born in February in the paternal branch. Here is the output for feature B4. Sorting was an interesting challenge because I needed to compare names while keeping the data structure intact. I used sort by first, which applies a high order function sort with a custom comparator. The comparator extracts the first name, converts it to a string, and then compares it alphabetically using string. This function outputs the list sorted alphabetically, making it easier to navigate. Here's the output for feature B5. To demonstrate list transformation, I created change name to Maria, which renames all occurrences of Mary to Maria. The function does the following. Defines a helper function replace name, which checks if the name is Mary and replaces it with Maria. Uses map to apply this function to every name in the family tree. The output is an updated family tree with the modified names. The only limitation I have in my code is that for feature B6, all the members named Mary in the paternal branch have been updated to Maria. However, not all the members in the maternal branch has been updated. The solution to my limitations is documented in my report as well as more details on the features. Here's the output for feature B6. In conclusion, through this program, I demonstrated key functional programming techniques such as high order functions, used extensively for list processing, for example, map, filter, sort, and append. I used recursion, for example, used an oldest living member to loop through the list without explicit iteration, and lambda expressions, for example, using it to define small anonymous functions for filtering and transformation. By combining these concepts, my program effectively processes and manages family tree data. Thank you for watching, and I hope this demonstration helped you understand how to work with lists and apply functional programming concepts in Scheme.